Okay, now let's look at the application problems. So now we get to the hard ones. Number A, two fishing boats have the same average speed in still water. Let's call the speed x. They leave the dock at the same time. One boat heads upstream and the other downstream. And then at a certain point, boat A is 56 kilometers downstream and boat B is 24 kilometers upstream. The average speed of the current is 8 kilometers per hour. What is the average speed of the boat in still water? Okay, so now for this one, we have to remember that distance equals time times speed times time. Okay, so the fishing boats have the speed of x, right? But then one boat heads upstream and the other heads downstream, right? And the current is 8 kilometers per hour, so that means the actual speed of one boat is going to be so the actual speed of one boat is going to be one's going to be x plus 8 and one's going to be x minus 8, and that is because the boat that's heading downstream, that's going to become x plus 8 because it travels with the current, right? So if we see that the river is flowing like that, right, then if we have the boat here and the boat's going at a speed of x, right, but the river is going at a speed of 8, right, so 8 kilometers per hour, that means the total thing, that's going to be x plus 8 for this boat. And the same thing for the boat heading the opposite direction. So like it's like when you're riding an escalator, but then you're walking on the escalator. And so if you walk on the same direction as the escalator, then you get faster because you get the speed of the escalator added to the speed of you, right? But then if you try to go on the opposite direction as the escalator while the escalator is still moving, don't do that because that's dangerous. But then you will be slowed down because the escalator is kind of negating your speed, right? And so if you try to go this way in the speed of x, but then the current's pushing back at you with the speed of 8, then your total speed is going to be forward, but still x minus 8, right? And so that's why you have these two speeds, x plus 8 and x minus 8. And then at a certain point, boat A is 56 kilometers downstream and boat B is 24 kilometers upstream. So what this is telling us is that if the time is the same, right, at the when a certain time has passed, right, boat A is 56 kilometers and boat B is 24 kilometers upstream. So that means this is the speed, and then the distance is 56 kilometers, right? And if this is the speed, right, then the distance is going to be 24 kilometers. And this was all done in the same time because this is at a certain point in time, right? And so since we have time as constant, so the time is equal, and time is distance over speed, then we can say that distance, 56, over speed, x plus 8, this is going to be equal to distance over speed, right? So the time for this one, so the time for boat A is equal to the time for boat B, which is going to be 24 over x minus 8, right? And so this is the equation that we have here, and now we're going to solve this thing. Okay, so basically what we want to do is we just want to make it cross multiply, and then we're done, right? 56, let's do this in black. 56 times x minus 8 is going to be equal to 24 times x plus 8, right? 24 times x plus 8. And then we can divide by 8 each side, so 7 times x minus 8 equals 3 times x plus 8. So this gives us 7x minus 56 equals 3x plus 24. So that gives us 4x equals 24 plus 56. And that's going to be, let's just say 24 plus 56. And so that means x is going to be this divided by 4, right? So that's going to be 6 plus 14, which is 20. That means x is 20. So the average speed of the boat, right? So average speed of boats, sorry, my handwriting is very, very bad, is going to be 20 kilometers per hour. And that is our answer. Number B, you have to skip because that one has two variables and one one expression and one equation, so that's impossible. Number C, Ryan and Marissa ride a tandem bike to get ice cream. Okay, so first, what a tandem bike is, when you have that bike that's like really long and it has like 2 seats on it, like this, and then you have the handle, and then you have 1 seat, and then you have another handle, like, and then you have another seat like that. I don't actually know if you have a handle. Yeah, I think you do though. Yeah, so this bike with 2 seats designed for, 2 people like that, for like 1 set of pedals, and then the other person like for the other set of pedals, right? That's yeah, so this is a tandem bike. And so Ryan and Marissa ride this to get ice cream. If only Ryan pedals, it takes 32 minutes to get to the ice cream shop, and if only Marissa pedals, it takes 41 minutes. How long to the nearest minute does it take if both Ryan and Marissa pedal? Okay, so this is basically just a problem where you just add their speeds, right? So Ryan's speed, speed. This is gonna be 1 over 32, right? 1 over 32, and then distance per minute, right? Distance per minute. Because the distance is always going to be the same, and we don't care what that is, right? And then Marissa, 41 minutes, right? Marissa speed, that's going to be 1 over 41 distance per minute. And so if they pedal together, then their collective speed together, their speed is going to be 1 over 32 plus 1 over 41, right? And then how long to the nearest minute does it take? Let's say that the time it takes is x minutes, right? X minutes, right? And then we want to go the d distance in x minutes, right? So that means that the speed has to be 1 over x. So this thing equals 1 over x. Sorry, 1 over x, right? Also, you might be more familiar with this version, x over 32 plus x over 41 equals 1. This is basically the same thing, because you just divide by x, right? You basically just divide by x, and then these two cancel, and so you get 1 over 32 plus 1 over 41 equals 1 over x. And that's basically what you see here, okay? So basically we have that, and then now we can just get what this is. What is it? 32 and 41, they have nothing in common, so it's just going to be 32 times 41. And then 41 plus 32, that's going to be 73. And then 32 times 41, what is that? 32, 8, 12, 13, 12. 13, 12. This is going to be 1 over x. Therefore, x must be the reciprocal of this, which is 13, 12 over 73. And so that is our answer. Oh, but that isn't our answer yet, because we have to write it out. It will, what did the problem say? To the nearest minute. Okay, so using my calculator, it says that 1312 over 73 is going to be equal to 17.97. And this is pretty close to 18, don't you think? So, how long to the nearest minute does it take if both Ryan and Marissa pedal? So it will take 18 minutes. And there's our answer. Oh, period. Boop. So that was the application problems, and I hope you all understood.